Hi guys, this is the Science Chef. In this video, we'll be learning about the IUPAC nomenclature of alcohols. If you want to watch more of these tutorials, please like this video, subscribe to our channel, turn on the notification bell, and we'll be right back after this break. Thanks for being there. Alcohols, also known as alkanols, are organic compounds with the hydroxyl group as their functional group. They have the general formula CnH2n+1OH, where N is greater or equal to 1, or ROH, where R is the alkyl group. They can either be aliphatic, example ethanol, butan-2-ol, or aromatic, such as phenol, 2-methylphenol, etc. Without much ado, let's name the following organic compounds. You may need to watch our video on the IUPAC nomenclature of organic compounds to have a better understanding of the general principles of naming any aliphatic organic compound. Click on the link in the description to watch it and our other tutorial videos. These compounds are alcohols because they possess the hydroxyl group OH as their functional group, so their names will end with "ol" as the suffix. In our first compound, the carbon chain has 2 carbon atoms without a substituent, so its root name is ethan and not eth, because the systematic format of naming alcohols is prefix plus alkanol. The functional group is attached to the first carbon. Its position is not really important as it will always be on carbon 1. So combining the root and suffix, the name of the compound is ethanol. In the next compound, there are 4 carbon atoms, out of which 3 make up the longest carbon chain and 1 is a methyl substituent. Its root is therefore propan. Recall from our introductory video that the longest continuous carbon chain can be in any direction. It must not necessarily be horizontal or vertical. Numbering from any side gives the functional group the positional number of 2 and the suffix 2-ol. Since the methyl group substituent is also attached to carbon 2, then the prefix of the compound is 2-methyl. Therefore, the name of the compound is 2-methyl-propan-2-ol. The third compound contains 4 carbon atoms in its chain, giving it a root, butan. The OH functional group will take the highest priority when it comes to numbering the chain, so we number it in a direction that assigns the lower possible positional number group, which is 1 and not 4, therefore giving it a suffix 1-ol. With the priority given to the functional group, the positions of the chlorine and bromine substituents will be carbons 2 and 3, with the prefix 2-chloro and 3-bromo respectively. Combining the prefix, root and suffix and arranging the prefix in alphabetical order, we obtain 3-bromo 2-chloro butan-1-ol as the name of the alcohol. The longest continuous carbon chain bearing the functional group in the last compound contains 5 carbon atoms, so its root is pentan. Numbering it from right to left assigns the lower positional number 2 to the hydroxyl functional group with the suffix 2-ol, and the methyl and chlorine substituents positions 3 and 5 with the prefix 3-methyl and 5-chloro respectively. Arranging alphabetically, the name of the compound is 5-chloro 3-methyl pentan-2-ol. Having known how to name aliphatic alcohols, let's learn how to name the next set of compounds. These are aromatic alcohols because of the presence of the benzene rings and the hydroxyl groups in their molecules. These rings are substituted benzene rings because of the substituents on each of them, be it the principal functional group or not. So the root and suffix names of these compounds will be phen and ol respectively. The root is derived from phenyl C6H5, a hydrogen substituted benzene ring. In the first aromatic alcohol, there are 6 positions on the benzene ring to which the functional group can be attached, and being the only substituent, it is attached to carbon 1. Note that on the substituted benzene ring, carbons 2 and 6 are also known as the ortho or O positions. Carbons 3 and 5 are known as the meta or M positions, while carbon 4 is the para or P position. Since the format for naming aromatic alcohols is prefix plus phen plus ol, then the name of the compound is phenol. In the next compound, there are the hydroxyl and amino groups on the benzene ring. Since the OH group is the principal functional group due to its higher priority, then the amino group is the substituent. So, in numbering the ring, we start from the carbon to which the principal functional group is attached and number it in a direction that will give the substituent the lower possible numbers. Since the amino substituent is attached to carbon 4, irrespective of the numbering direction, it forms the prefix 4-amino or para-amino. Hence, the name of the compound is 4-aminophenol or para-aminophenol. In the third compound, the ring is numbered in the anti-clockwise direction that gives the methyl substituent a lower positional number of 3 and not 5. And being a meta position, it forms the prefix 3-methyl or meta-methyl. Therefore, combining the prefix, root and suffix, we obtain 3-methylphenol or meta-methylphenol as the name of the compound. From the fourth compound, we can see that apart from the principal functional group, there are two other substituents attached to the benzene ring. So we must be very careful when numbering the ring to ensure that the sum of the positional numbers of this substituent is as low as possible. So the right direction in this case is anti-clockwise, which gives the chlorine and methyl substituents positions 2 and 5 respectively, as against if numbered in a clockwise direction. So the appropriate prefix is 2-chloro-5-methyl, while the name of the compound is 2-chloro-5-methylphenol. In the last compound, the COCH3 substituent is called the acetal group and is attached to the fourth carbon or para position. Hence, the name of the compound is 4-acetylphenol or para-acetylphenol. That's simply how to name alcohols. In our next video, we will learn about the classification of alcohols. Endeavor to keep a date. If you enjoyed this lesson, like this video, leave your comments, subscribe to our channel, and follow us on our social media platforms. Thanks for watching.